Hello everyone, and then welcome to another video. Okay, so this video will be a very concise video on limits and continuity. Okay, so in case you are new to this channel, I would urge you to subscribe to the channel, like the video, share, and then in case you have any questions, just leave them in the comment section and then I will reply to them as soon as possible. Okay, so once you subscribe, make sure to turn on your bell icon so that you don't miss out on any uploaded video. Okay, right, without further much ado, let's just dive right into this video. Now, we know limits, and then maybe continuity might be your first time hearing this concept, but as for limits, it's general. Okay, right, so for limits, we know that we have it could be right-sided or left-sided. Okay, so we have two-sided limits. Okay, it's either the right side or the left side. Okay, so let's say we have maybe a limit. Okay, and then let's say we have x going into 0. Okay, and then we have limit of 1 on x. Okay, right, so once we bring a negative sign over here, it means that we are taking the limit along the left-sided. Okay, so when this happens, we have a negative infinity. Okay, so this the left-sided limit. Okay, right, and then similar to the right-sided, we have x going into a positive 0. Okay, we have 1 on x. Okay, so this will give us a positive infinity. Okay, so this a right-sided. Okay, a right-sided limit. Okay, right, I hope this was very clear. This is very concise, very simple, straight to the point, so you won't even burst a bubble trying to understand this. Okay, so now let's dive right into the nitty-gritty concept. Okay, right, so we know that we call something continuity. Okay, so for a limit to be continuous, it has to have an exact value. Okay, so let's say we have limit of x going into let's say 2. Okay, and then we have 1 on x. Okay, so once you try solving this, you end up with limit of x going into 2. So we have 1 on 2. We substituted the x with 2. So this is a continuous limit function. Okay, because we were able to end up with an exact value, 1 over 2. Okay, but provided we end up with something like 1 over 0, it becomes undefined. Okay, so in case you have x going into 0, you end up with 1 over 0. So this is undefined. Okay, undefined. Right, so this is undefined. Then once we end up with something like let's say we have a limit of let's say x going into 0, and then we have s squared on maybe x cube. Okay, so when you compute this, you end up with 0 on 0, and then this, we also refer this as indeterminate. Okay, this is an indeterminate because we cannot determine the exact value of this limit, but from here you can notice that we have 1 on 2 is determinate. Okay, so it's continuous. 1 over 0 is undefined. Okay, and then 0 over 0 is indeterminate. Okay, this indeterminate. Okay, right, so note these 3 points. Okay, you have continuous, undefined, okay, and then this indeterminate. Okay, right, so let's dive right into a more complex concepts. Okay, right, so for continuous limits, we have other examples. Okay, so you could end up with limit of maybe s equals s going into maybe 3, and then you have maybe 1 over x plus 2. So all you have to do is just substitute, so you end up with 1 over 3 plus 2, and that will give us 1 over 5. So this is also continuous. Okay, this also continues. You could go further with other examples, okay? So you could have maybe we are still working on continuous functions, okay? So you could have also a limit of x, maybe x going into 2, and then you have what? X divided by what? X plus x squared. So once you do the substitution, you end up with what? 2 divided by what? 2 plus what? 2 squared, okay? And then that will give us what? 2 divided by what? 2 plus 4, okay? And then we end up with what? 2 on 6, which is also equal to 1 on 3, okay? So you could just proceed with all that, okay? So this is just an introductory to limits, okay? You can notice that limit is quite straightforward and then easy to understand, okay? So now let's move on to what? Limit along curves, okay? So you have what? Limits, okay, along curves, okay? Alright, so we have limit along curves. Now, so in case you are given a function of x and then a function of y, okay? So let's say we have let's say if we have a certain function of x being equal to certain x of t, okay? Let me clean this one. So we have what? A certain function of x being x of t, okay? And then a certain function of y being what? Y of t, okay? It means that you'll be given a certain limit and then you'll be given another function of x, okay? And then another function of what? Y, okay? So all you have to do is just substitute, okay? You do a simple change of subject, and after that you substitute into the limit, okay? Just like how we did simple substitution over here, okay? Now, so let's say you've been given a limit, okay? So you've been given a limit with what? X and then what? Y, okay? And then you've been given x value to be a certain value, okay? And then y value to be another value, okay? And then you've been given what? The function of x and y, okay? So all you have to do is just change the subject per these functions, and then you substitute the what? The given values for x and y. So x naught will stand for or represents a specific value, okay? Y naught also represents a specific value. So once you do the expansion, you end up with what? A certain limit, okay? So let's say we substitute this with a certain limit t, okay? So t going into what? T naught, okay? That's why I initially stated that you'll be doing substitutions, okay? So all you have to do is just do your simple substitution, okay, into the function which is f, okay? So you could end up with what? Certain function, okay? We have what? This function x of what? T naught, okay? And then we have the y function of what? Y of what? T naught, okay? So this is how your functions will look like. Now let's take an example so that these become easy to understand, okay? So we have to find the limit of what? A function, let's say x and y, okay, at specific points, okay, and then at specific functions, okay. So let's say x is given as a specific function and then y is given as a specific function. So let's take an example, okay. So let's say we have to find there's an example. So find the limit, okay. Find the limit as xy, okay. Find the limit as xy, which are going into what? 0, 0. So this is what I was referring to, this portion, okay. You'll be given xy and then you'll be given what? Their functions, okay. Right, let's proceed. And then for x, so you've been given the function, okay. That's f of x or y, okay? We've been given this function, okay, to be equal to minus xy, okay, divided by what? X squared plus y squared, okay? So now, this is the function, okay? This is the function, okay? This is the function over here. So we've been given the function over here. Now, let's see whether we'll be given specific functions for x and y, okay? Right, let's see. So, let's proceed. Now, so we are looking at what? Limits along curve. So, we've been given this function along the curve, okay? So we've been given the function along the curves. The first curve is y equals x, okay? So this is the first curve, okay? Y equals x. So you've been given, let's say this a, okay? Let me number this as a so that it becomes simple to understand. So we've been given y, the function of y equals x, okay? So all you have to do is just do a simple change of subject, okay? And then we substitute and then we insert our values, okay? Now, let's see how we go by that, okay? So, and then we have b, okay? So we have b to go to 2s squared, and then we have c, okay? C to be s cube, okay? Now, this s cube is equal to what? Y. Note that these are equal to y's, okay? These are equal to y, just like this is equal to x, okay? So y equals x, 2s squared equals y, and then what? S cube equals y. Now, let's start from y equals x, okay? So let's start from y equals x. Let's see how you go by that, okay? Kindly pay rapt attention to this concept because it might sound confusing, but once you follow, it will look very, very simple. Now, we know that we've been given a function of y equals x, okay? This is what we've been given. And then this is the general expression, okay? So let's say we take the limit, okay? So let's say we take the limit of t to be 0, okay? And then that will give us what? Minus x y divided by what? S squared plus y squared. Note that our x is equal to what? Our t, okay? So this is something like s going into 0, so t going to 0, s going to 0. Now, and then we've been given this function, okay? So all you have to do is just change of subject, okay? So from here you can notice that y is equal to x and then x is equal to y. So most definitely it means that y is equal to t and then t is equal to y, okay? Because I initially stated that t is equal to 0 or t is going into 0, and it means that or t is approaching 0, it means that s is also approaching 0. So from here you can notice that we have what? Minus t, okay, multiplying what? T divided by what? T squared plus what? T squared. That's why I initially stated that t is going to 0, and then it means that x is also going to 0. And then since we have y is equal to x, it means that we have what? Y is equal to t, okay? And then what? T is equal to what? X, okay? This is what we made, okay? So that's why we've been able to substitute this, okay? So wherever you find t, you substitute that with what? X. Sorry, whenever you find x, you just do the substitution with t. The same thing applies to what? Wherever you find y, okay? So from here we have what? Minus what? T squared, okay? And then divided by what? 2t squared. So this will give us what? Minus 1 on what? 2, because the t squared will cancel t squared. Now, from here you can notice that this exact value is what? Continuous, okay? This is continuous because we've been able to end up with what? An exact solution, okay? An exact solution. Now let's proceed to what? The b, okay? I hope the first example was quite easy, okay? Now let's move on to b. So now b, we have what? 2s squared to be equal to y. So we know that we have our limit t approaching 0, and then we have what? Minus x y divided by what? S squared plus y squared. And then since we know that t is approaching 0, it means that s is also approaching 0. So all we have to do is just substitute the t into here and then make each of them the subject, okay? So from here we have what? From here we have 2x squared is equal to what? T, okay? That's y, okay? So let me rewrite this in this format so that it becomes simpler, okay? Now, so we have y. So since we are substituting x with t, we have y equals what? 2t squared, okay? Now, let's make s the subject and then substitute that with t, okay? So from here we have what? S to be equal to root of what? Y on what? 2. So this is the same as s is equal to what? So that's from here, okay? Making s the subject from this expression, okay? We have s is equal to root of y on 2, and then since we are substituting x with t and then t with x, we have what? And then substituting t with x and then t with y, so we have what? This t on what? 2, okay? Now let's try substitute that into this expression, okay? So we have what? Minus what? X. So x is what? Root of what? T on 2, okay? Root of t on 2. So we have negative what? Root of t on 2, okay? And then you multiply that by what? Y. So y is what? 2t squared, okay? So we have 2t squared, and then you divide that by what? S squared. S squared is what? This expression. So we have t on what? 2, okay? All squared, okay? And then plus what? Y squared, which is what? 2t squared. So we have what? 2t squared all squared. Now, from here you could just do simple you could just implement your simple algebra, because we know that ln of t is approaching 0, okay? So it means that every t you see here is approaching 0, okay? So it's either you use that, or you could first break this expression down, okay, so that you get it in the simplest form, okay? So with that being said, let's see what we could do. So we could put t, okay, equal to 0, okay? So when you put t equal to 0, you could notice that from here we will get what? 0, okay? So t on this thing will give us 0. So root t on 2 will give us what? 0, multiplied by what? This will also give us 0, divided by, most definitely this will give us 0, this will also give us what? 0, okay? So our second example will give us what? Entire solution of what? 0, okay? Now, notice that this was quite simple, okay? So let's take the last example so that you get to fully understand the concept, okay, of limits along curves, okay? So this is the last example, okay? So we have s cubed equals y, okay? So we have c, okay? So we have s cubed equals y. So the same approach, first we make y the subject, okay? So you know that y is already what? S cubed, okay? And then when we replace x with t, we end up with what? T cubed. And now we also make what? X the subject, okay? So when you make x the subject from here, you end up with what? X being equal to cube of y, okay? Or cube of y. Now, substituting y with t, okay? Substituting y with t, you end up with what? This expression. Now, all you have to do is just substitute into the main expression. So we have what? Limit of what? T, okay? Limit of t approaching 0, okay? And then we have what? Minus x y divided by what? X squared plus y squared. Okay, so all you have to do is just do your simple substitution. So you know that x is what? Okay, so you know that x is cubic of what? T multiplied by y. Y is what? T exponent 3, okay? And then you divide that by what? S is what? Okay, S is cubic of what? T all squared, okay? Plus y. So y is what? T exponent 3, okay? All squared. Now, let's do a simple calculation, okay? So from here, you could try expand this, okay? Or you could just try and leave it like that. So you could notice that this will cancel this, but you will have one remaining over here, okay? And then this will cancel this, but you have one remaining over here. So we have what? 1 times 1 is 1 divided by what? Divided by cubic root of what? T plus what? T cube, okay? So now we could just substitute t equals 0. So the trick over here is that you could either substitute your t equals 0 over here so that you end up with your answer straightforward, or you could decide to break the expression down just like I just did over here, okay? So you could have done the same thing over here. So cancel this, you end up with 1 over here, and then cancel that, remaining 1 over here, so that you end up with what? 1 over what? Root of t on 2, okay, plus 2t squared, and then still you end up with what? 1 over 0, okay, that's 0, okay. So we didn't bother ourselves going through that, okay, but you could also bother yourself going through that. And then at the end, you end up with what? 0, okay? Right, so this question also gave us a 0, okay? So from here, you can notice that we only ended up with what? A continuous function with the first example, okay? First example, but the remaining gave us what? An indeterminate expression, okay? Indeterminate, because indeterminate or undefined, okay? So from here you can notice that this will look like an undefined function. That's only when you break this expression down, okay? But once you don't break it down, you just leave it this way, just like how we just substituted the 0, the t equals 0 over here. You just end up with what? An indeterminate function, okay? But once you break it down, you end up with something like 1 over 0, okay? And then 1 over 0 is what? Undefined, okay? Right. Now, this was quite interesting, okay? So now let's look at the last item, okay? Before we move on to what? Continuity, okay? Right. Let's look at the last item. So the last item is what? Finding the limits of what? General functions, okay? So let's say you are told to find the limits along the curve, okay? You have to find the general limits along the curve. So we have what? So this is quite similar to what we initially did. So initially we calculated for what? Limit along curves, okay? So for here we are trying to calculate what? The general limits and limits along the curves, okay? So let's use a scenario, okay, to explain this concept, okay? So we have what? Let's say you've been given a function of f of x, okay? You've been given a function of f of x, okay? And then you are told that this is the limit, okay? And then the limit is given as what? The function of x and y. So we have what? X, y, okay? And then you are given what? X naught, y naught, okay? So x naught, y naught. So from here you can notice that it's similar to what? Taking the limit of curves, okay? Now, we know that this will give us our limits, okay? So this is the limit along any smooth curve, okay? So this will give us limits along any smooth curve, okay? This is the limit along any smooth curve. So when the function f of x, y is equal to the limit, gives us the limit or is equal to the limit at these points, okay, s naught, y naught, we will get the limit along the smooth curve, okay? So let's take an example so that we get to understand the entire concept, okay? So for example, we have what? We've been given the limit, okay? Limit of x, y, okay? And then you are given the x naught, y naught to be 0, 0, okay? And then this, let's take the same example, okay, as our reference, okay? S squared plus y squared, okay? Now, and then you are given the limit points, okay? So the limit points being what? The limit at which what? X is approaching 0, and then we have 1 on x, okay? So this is how you go by that. Now, let's say you've been given this expression, okay? This expression, then you are told to find the expression at a, okay? So you are told to find the expression at a, okay, when y is equal to 4, okay, b, okay, when y is equal to 4x, okay, and then c, okay, when y is equal to what? X plus 3. So from here you can notice that this is quite different from what we initially calculated. So from here you notice that we were given y equals x, 2s, y equals 2s squared, and then y equals s cubed, and then we are told to find the limit as xy, okay, approaching 0, 0, and then for this function, okay. Now this is quite different, okay. We are told to find the general limits and limits along the curves, and then we are given equation, okay, in the form of a limit, okay, at x, y, 0, 0, and then taking the same expression. But at this point we have what? The limit of x approaching 0 at what? 1 on x, okay. So now let's see how we solve this, okay. Now let's proceed from here. Okay, so let's take a look at this example, okay. Now, so provided you are given something like this, okay, so we have what? You are still under what? General limits and what? Limits along the curves, okay. So once you are given an example of this format, okay, so initially we weren't given x, y approaching what? Maybe let's say 1 and 4 or anything of this format, okay. We weren't given anything similar to this. We were just given the limit with this expression, then we are given what? T approaching what? 0, and then we are to do change of subject and then substitute that, okay. After that we substituted the limit to get our final answers. But this is a bit different, okay. So you are given limit at x and y, and then you are given the value for x and y, okay. So this is x is 1, y is 4, okay, and then you are given this expression now, and then you are told to solve this along y equals 4, y equals 4x, y equals what? S plus 3, okay. So let's see how we solve this, okay. So from here, this is quite simple. We know that y equals 4, okay, it's already been given, and then from the limit you can notice that y is also 4, and then most definitely it means that s is also equal to 1. So from here you will notice that we have this limit, okay, giving us y, x and y being what? 1 and what? 4, okay, 1 and 4, okay, and then we have xy, s squared plus y squared, okay. So it means that this could be also represented as t approaching what? 1. Note that initially I stated that whenever you see or come across t, it means that we are referring to x, okay. So this is similar to or the same as x approaching 1, okay, Okay, so when t or x is approaching 1, you could notice that we have what? This changes to what? Ty over what? T squared plus what? Y squared. So all you have to do is just substitute your t and y values. Okay, so we have minus 1 multiplying y, which is what? Already given us what? 4. Okay, and then you divide that by what? T, which is 1 squared plus what? 4. Okay, which is what? Squared. Okay, so once you do the simple computation, we have minus 4. Okay, and then this is what? 17. Okay, this is 17. So 4 minus 4 on 17. Now, one thing I didn't initially state is that whenever you come across what any expression of this format, okay, and then you are given 3 functions, okay, and then once the respective answers for all the functions are equal, we then state that the limit exists. Okay, so once all these 3 functions are substituted into this limit and we end up with the same answer, it means that the limit exists. Okay, once you don't end up with the same answers, it means that the limit doesn't exist. Okay, right, so let's proceed from there. So let's take the second example. Okay, so we have y equals 4x. So this was what? Y equals 4. Okay, this was I. Let's look at I. So I is what? Y equals what? 4x. So the same principle applies. Okay, we have what? Limit t approaching 1. Okay, it means that we have minus t, okay, y divided by what? T squared plus y squared. So from here we have what? Y being called 4x. Okay, and then we already know that since t is approaching 1, means that x also approaching 1, and then once we see t, we just substitute that with x, or once we see x, we substitute that with what? T. So most definitely this is equal to what? 4t. Okay, so from here you could notice that this entire of x, okay, we have what? Minus t, okay, multiplying what? Y is what? 4t. Okay, 4t. So you can't have something like t minus t times 4x. No. Okay, it's either we leave this the way it is. Okay, it's either we go by limit of x approaching 1, and then we come back here and use what? X minus xy, and then what? T squared plus y squared, or we just introduce our t and then we substitute all x with t. Okay, so now we have what? Divided by what? We have t squared, okay, plus y squared. Y is what? 4t. So we have what? 4t. So this is all what? Square. Okay, now let's do a simple calculation. Now we know that t is equal to 1. Okay, we know that t is equal to 1, so we have what? Minus 1 times 4. Okay, because 4 times 1 is 1, and then divided by what? 1 plus what? This is what? 4. So 4 is what? 16. Okay, right, so from here you can notice that we have what? Minus 4 on 17. It's just the same as what we had for what? Y equals 4. Okay, it's just the same as what we had for y equals 4. Now let's look at what? Y equals x plus 3. Okay, so from here you could just pause the video and find out whether you would be able to what? Solve for y equals what? X plus what? 3, right? X plus 3. Now let's proceed from there. So now we notice that since we are dealing with t, okay, or substituting x with t, we have what? Y to be equal to what? T plus 3. Okay, t plus 3, and then we know that our limit is equal to what? Limit at t approaching 1 means that it's similar to what? X approaching 1. Okay, and then we have what? Minus ty divided t squared plus y squared. Okay, so we know what y is, and then we know our t already. So we have what? Minus t multiplying y. Y is what? T plus what? 3. Okay, and then we divide that by what? T squared plus what? Y is what? T plus 3. So we have t plus 3 all squared. Now let's try solving this. Okay, so we have what? Minus, so this multiplying that, we have minus t squared, and then minus t multiplying positive 3, we have minus what? 3t. Okay, and then we have what? T squared. Okay, we have t squared plus, this will give us what? T squared. Okay, and then we have what? Plus 6t. Okay, and then we have what? Plus 9. Okay, plus 9. So I just expanded this. Okay, it's quadratic, so we'll end up with a quadratic expression. So we have t squared. Okay, and then we have t times 3, that's 3t, multiplying 2, that's 6t, and then we have 3 exponent squared, that's 9. Okay, so from here let's try substituting t equals 1. Okay, because you know that t is equal to what? 1. Okay, right, so we have what? This is minus 1 squared, and then minus what? 3. Okay, divided by what? This 1 squared, that's 1, plus 1 squared, plus what? 6 t, that's 6, and then plus 9. So from here we have what? This is minus 4. Okay, from here, so we have minus 1, minus 3, minus 4, and then we have what? 1 squared, that's 1, 1 squared, that's 1, this is what? 2, and then we have 8, this is 17. Okay, 17. Okay, so now you notice that all these three answers are equal, so it means that the limit exists. Okay, since we know that all of the limits have the same value, it means that what? The limits exist. Okay, now let's look at continuity, and then we call this video a day, or we call this tutorial a day. Now let's look at continuity. Okay, let's look at continuity, the concept of continuity. Okay, now this is the concept of continuity. So for continuity, we know that the limit have the function of x and y, and then the function of x. So once we substitute the value for x and y, that's x naught and y naught, just like how we've been substituting over here. Okay, just like how we've been substituting over here, you end up with what? Specific value, and then that specific value will tell you whether your limit is what? Continuous or not continuous. Okay, so once you end up with what? A specific value, okay, it means that your limit is what? Continuous. But once you do not end up with what? Specific value, your limit could be what? Discontinuous. Okay, now let's see. These are the three main concepts you need to know. Okay, these are the three main concepts you need to know. Now, for continuity of limits, the composition of a continuous function is what? Continuous. Okay, so just like how we calculated, and then we ended up with what? Respective values, something like minus 4 and 17, 1/2, all that. Okay, it means that what? The composition of the continuous function is continuous. Now, a sum, difference, or product of continuous function is continuous. Okay, we have what? The sum, difference, or product of continuous function has to be continuous. Okay, and then now a quotient of continuous function is continuous except where the denominator is 0. So now we know that a continuous function, the quotient of a continuous function is continuous except where the denominator is 0. Okay, so let's say we have what? Let's take an example. Okay, so let's say we have a limit of x, y. Okay, x naught, y naught, and then we are given the x naught, y naught to what? 0, 0, okay, and then we are given this expression xy over what? X squared y squared. Okay, I've decided to use the same example so that you get to easily understand. Okay, so from here we could notice that the denominator, okay, so this is a quotient, okay, quotient sounds like a fraction. So we were told that the quotient of a continuous function is continuous except where the denominator is 0. So now let's check out the denominator, the value for the denominator. Okay, so we have what? S squared plus y squared. So this is what? 0 squared plus 0 squared. So we end up with what? A value of 0. So it means that this quotient is not what? Continuous, because the denominator is what? Equal to 0. Okay, the denominator is equal to 0. Let's say we want to find out whether it's continuous or not. Okay, whether a quotient is continuous or not. Okay, so the same expression, okay, with the limit x, y, okay, and then we are given the limit as 1, 4. Okay, so let's check the denominator. So we have x squared plus y squared. Okay, so we have what? 1 squared plus what? 4 squared. This is what? 17. So from here you can notice that this is not equal to 0. Okay, so it means that the quotient, in case we were given these function, these x naught and y naught value, the quotient will be what? Continuous. But once we are given 0, 0, and then you substitute, and then you end up with the denominator being equal to 0, it means that the quotient is not what? Continuous, or the quotient is what? Discontinuous. Okay, right. Now this brings us to the end of the continuity concept. Okay, so in case this video was quite helpful to you, I know I was a bit fast. Okay, I was a bit quick with the explanation because I know that this is just the basics, so you get to understand it easily. Okay, so once you are able to grasp the concept, and then you're able to understand the concept of limits, okay, curves along limits, general limits, and limits along curves, and then continuity of limits. I would urge you to subscribe to the channel, like the video, share, and then in case you have any questions, kindly leave your questions in the comment section. I will swiftly respond to them as soon as possible. I would urge you to also turn on your post notifications so that you don't miss out on any uploaded video, and I will see you in the next video.